Good evening, all of you. I hope I'm audible. If I'm not audible, please drop a text in the chat box at any time. Uh, Today we are going to discuss assignment 6, the previous year assignment 6 questions, which is related to the second order transients and Laplace transformations. First, we go into the question one. The question one is find out the I of t. Sorry, yeah. Fi- Find out the I of t for t greater than 0 in the circuit of the figure given below. Means we have to find out the current flowing through in this loop. After that, at t equal to 0, the switch is going to be open. Then the circuit will be like this, right? After t equal to 0, which is 60 ohms, and this is 40 ohms, and 1 millifarad, and 2.5 Henry. We need to find out the current. What happened? Is there any issue? Yeah, if you have any doubt, you can unmute at any time and you can ask the question. We need to find out the current through this. What is the behavior of the yeah, just sorry, just I'm sharing the queries. Yeah, what is the behavior, steady state behavior of the inductor and capacitor? Capacitor will act as a open circuit. Inductor will act as a short circuit, right? Right. I'm redrawing the circuit t less than 0. What's the t less than 0? This switch is in closed position. So the 10 ohm resistor and the 60 ohm resistor. The capacitor is acts as an open circuit and the inductor is acts as a short circuit. This is the circuit for t less than 0, right? Here the voltage is 30 volts and here the current is resistance is 10 ohm and here it is 40 ohm and here it is 60 ohm. Here it is VC of 0 minus, here it is IL of 0 minus, right? Here it is open circuit, so the current through this path is, I can write 0. Why? Because here it is the capacitor is fully charged. Okay, okay. Thank you, Ravindra. Thank you. Yeah, I will repeat this again. Am I audible now? Yeah, yeah. Thank you. Yeah. Yes, yes, please. Yeah, yeah. Okay. Those problems we can take after this session. I mean, this only five questions. It hardly takes 20 to 30 minutes only. After that, ha ha. Oh, okay, okay, fine. Thank you. Yeah. Actually, the switch is opened at t equal to 0. After opening that switch at t equal to 0, the circuit seems like this one. Only the circuit path is this one, right? After the switch is open. So I redrawn the circuit for t greater than or t greater than 0 case. What about the t less than 0 case? It is a steady state period. In the steady state, the capacitor is acts as an open circuit and the inductor is acts as a short circuit, right? With that conditions, I'd redrawn the circuit for t greater than, sorry, t less than 0. In that case, I represented my capacitor with open circuit here and the inductor with short circuit. Okay. Here, the capacitor is open circuit which is connected in series with the inductor. Therefore, the current through this inductor is 0, right? That's why I represented IL of 0 minus that inductor current. In the previous case, it's 0. So what is my VC0? VC0 is voltage across these potentials. Sorry, this terminals is same as this terminal. So my VC0 is the voltage across the 40 ohms. So VC of 0 minus equal to voltage across the 40 ohms. Voltage across the 40 ohm resistor, that you can represent, you can write simply from voltage divide rule. The voltage, what is the voltage divide rule? The voltage divide rule says that the voltage across this 40 ohms is the total voltage into that resistance by total resistance, right? I can write like this: the total voltage is 30 volts into that resistance, that is 40 ohms, by total resistance, that is 40 plus 10, which is of 30 into 40 by 50, which is of 24 volts. Means here our capacitor voltage VC of 0 minus is 24 volts. The capacitor is charged to 24 volts. Yeah, we can copy this circuit. It's better. Yeah. Now the circuit seems like we have VC of 0, and now we have to find out the alpha and omega. What is the alpha? Alpha equal to R by 2L, right? Here resistance R equal to the total resistance, that is this 60 and 40 ohms are connected in parallel, so series. You can write 60 plus 40 by 2 into, what's the value of inductance? It is a 2.5 Henry. So we can write 100 by 4.5, which is equal to, sorry, 2 into 2.5, right? 20. Coming to the omega, what omega equal to 1 by root LC equal to 1 by, what's the value of L? It is 2.5 Henry and capacitance value is 1 milli. Which is also 1 by square root of 2.5 by 1000, which is you can write. Okay, right? So here alpha equal to omega. If alpha equal to omega, then what is the system nature? The system is critically damped. If the system is critically damped, what is the response of the current? The response of the current I of t equal to a1 of a1t plus a2 into e power minus alpha t, right? What's the a2? A2 here is IL of 0 minus, that is already we saw this thing, it is 0. Then how to find out this a1? You can apply the initial values. Initially LTL 0 plus by dt equal to, initially the inductor acts as a, inductor doesn't allow the sudden change of voltage, so the total capacitor voltage is applied across the inductor. Yeah. What is the value of IL? IL is the A1 of t, why? Because all are connected in series. A1 of t plus A2 into e power minus alpha t equal to Vc of 0 plus, right? Here this Vc of 0 plus we can write it is equal to 24. Then the value of L is 2.5. Just I shifted this L to this back, just divided. Okay, then you can differentiate this thing, this d by dt of a a1t into e power minus alpha t plus d by dt of a2 into e power minus alpha t equal to, okay, I'm just, this is a form of a UV form. So here a1 is constant here. Yeah, in this a1 is constant, so a1 into first UV U differentiation of V, right? Initial t into differentiation of e power minus alpha t means minus alpha t into e power minus alpha t plus e power minus alpha t. Differentiation of t means which is 1 plus a2 into minus alpha t e power minus alpha t equal to 24 by 2.5 means the value of 24 by 2.5, 24 by 2.5, which is equal to 9.6. Okay, so you can apply t equal to 0 at t equal to 0 initial conditions. This term, yeah, this term is going to be 0 and a2 is anyway 0, it is 0. E power minus alpha t value is at t equal to 0, the value equal to 1, right? So the value of a1 equal to 9.6. So here you know the A1 and here you know the A2. You can substitute A1 and A2 and minus alpha in this equation, you will get I of t. That is I of t equal to A1, that equal to 9.6 into t e power, sorry, plus A2 anyways it's 0 into e power minus alpha, that equal to 20 to t. So you can write I of t equal to 9.6 t into e power minus 20t. That is minus 9.6 t into e power minus, sorry, it's not minus, 9.6 t e power minus 20t. Coming to the next one is obtain the yes, yes, huh. Sorry, yeah, yeah, thank you. It is t won't be there, it is minus alpha. I, I think it's fine, right? Now it is fine, no? Now it is, but anyways these two terms are going to be zero, right? If you put t equal to 0, this term is going to be 0 and a2 is anyways 0. Huh, huh. Thank you for correcting. And coming to the second one, obtain the Laplace transform of the following function, sir. The function is t into e power minus t sine 2t u of t. Okay. You can find sine. What is the Laplace transform of sine at? Laplace transform of sine at equal to a by s square plus a square. Okay. If you delayed this function by some e power minus b times, if you delayed by e power minus b times, you can write like this: a by s plus b whole square plus a square. Okay. If you can differentiate the same term by, which is simply differentiation, minus 1 power n d by dt dn by dt power n into previous this function. Similarly, the this is the same form of this thing. Here, the term n equal to 1, the term b equal to minus 1, and the term a equal to 2. Okay, I'm just rearranging those things. It equal to minus 1 by 1 d by, yeah, here it is d by ds of, here our a equal to 2 by s plus 1 whole square plus a square is 2 square. So which is minus d by ds of 2 s plus 1 whole square plus 2 square. Okay. You can write like this, minus 2 into d by ds of we can write like this, just add to numerator. So this minus 2 differentiation of x power minus 1 means you can write like this, series of minus 1 into x power minus 2. That is minus 2 into minus 1 half s plus 1 whole square plus 4 minus 2. Again we have to differentiate inner function, right? D by ds of s plus 1 whole square plus 4. This minus and this minus will be cancelled, and this I am writing s plus 1 whole square plus 4 whole square. Differentiation of again this s plus 1 square, the 4 will be the 4 is the constant, and differentiation of this 4 is going to be 0, and the differentiation of s plus 1 whole square is, you can write s plus 1 right. I hope it's clear. Yes, yes. Sorry, it's 2, it's 2, final is 4. That is 4 into s plus 1. What's this? 4 into s plus 1 by s plus 1 square plus 4. So, and find out the Laplace transform of the following function. It is yeah, t power n by dt power n and delta of t. This simply is a differentiation function. You can write as power n. Find the Laplace transform of the following signal. The signal is given as 4 plus 3 into e power minus 2t. Okay. The different Laplace transform of the constant is 4 by s, and here the you can take constant outside, and the Laplace transform of e power minus kt means the Laplace transform of e power minus kt is 1 by s plus a. The same thing you can write 1 by instead of s. Here it is 2. Sorry. So the total function is 4 by s plus 3 by s plus 2, which is option B. Determine the initial and final values of the f of t if they exist. Okay, initial and final values means it's simply a signal. The step response of the signal is somewhere like this, and if it is at 0 degrees, what is the value which states the initial value? If it is at infinite, if it is constant throughout the period, I mean, if it is reached to steady state at infinite, what is the value of the system? This is the final value, and this is the initial value. Find out the initial value. Limit as stands to infinite s into f of s equal to limit as stands to infinite. Our function is s square minus 2s plus 1 by s minus 2 is here, s minus 2 into s square plus 2s plus 4 stands to infinite. You can common s cube, you can take a common s square, so which is 1 minus 2 by s plus 1 by s square. You can take s out, 1 minus 2 by s, and you can take s square outside, 1 plus 2 by s plus 4 by s square, which is limit s cube. The function remains same, 1 minus 2 by plus 1 by s square and s cube 1 minus 2 by s. Yeah, this s cube and this s cube will be cancelled. If you substitute s equal to infinite, then 1 by infinite means it is 0, and it is going to be 0, and it will be 0, it will be 0, it will be 0, and it's 0. And what's the final value will be 1 by 1, it gives limit. The initial value equal to 1. It means the system is starts with value of 1. If the system is not reached to steady state, then the value will be, the final value will be does not exist, or we can find out the final value also. Final value equal to limit as stands to 0 as into f of s, then s minus 2s plus 2 minus 2s plus 1. Okay, this is limit s into f of s as stands to 0. If you substitute s equal to 0 in this equation, it will be It means if the system, this system is does not reach to any steady state. This we can show some other, like, just a minute. I'm sharing from, yes, yes.